Okay. Now, just give you a little bit of background about myself. My name is James, and I'm a network engineer, and I work for EtherWAN. Now, today we're just going to talk about the topic, take your digital surveillance to the next level. So, in today's agenda, what we have is actually, I will talk about how network devices plays a really important role because the type of devices that you choose will actually affect the IP surveillance deployment. Now, I will also talk about the surveillance application. And different business sectors all use IP surveillance to monitor their assets and also minimize the risk with criminal activity. But there are others, like key benefits provided by IP surveillance as well. Okay, I will also talk about the surveillance architecture because this one here will actually affect the traffic flow. Also, I will talk how to optimize network transmission and installation. I will give you some troubleshooting techniques, and this is what we actually use every day. So to isolate technical issues. And all these skills can be actually implemented in the real case project, in a real case scenario. So let's move on to the next slide. Now here we have a typical IP surveillance system. What you can see is actually these are the cameras just for the monitoring purposes. And we have two NVR here just for recording. And also we have another PC just for doing the live viewing. Now, does anyone know if I place this hub in the middle, will that actually affect, in terms of traffic, will that actually affect any influence?
Compared to what? Compared to what? So you mean you want to put in the middle?
Hubs. Yeah, networking hubs. Okay, the thing is, if I put networking hubs in the middle, I will end up with a big collision domain and a big broadcast domain. Okay, the reason for this is actually for the hub, when any of the device send the frames either to NVR or either to PC-based NVR, whatever, but before they're sending this traffic, they were actually listening to the channel and see whether there are other device is doing the same transmission. Now, this will actually take tremendous time if you have many devices connected to the networking hubs. So the best way to avoid this is to use a management switch. However, if we actually deploy our management switch in the middle, we will still end up with a single broadcast domain. There is a possibility that the DHCP server or other type of services constantly send the broadcast traffic throughout the network. So in this case scenario, what we can have is the management type switch. We can actually doing the VLAN segmentation. Based on the VLAN segmentation, we can isolate through the broadcast domain. Let's move on to the next slide.
James.
Yes.
Awesome.
Yeah. Okay. Okay. Here we just said. We have the ITS. What normally ITS does is actually they use the IP camera with embedded IO sensor. With embedded sensors to monitor the traffic. Now, based on the information, they can further prevent traffic congestions. For the retail industry, we have real-time queue analytics. So what it does is actually they use a camera to monitor the customer. Let's say a customer standing in a queue. On average, how many minutes a customer will actually spend in a queue, so they can actually find out or by pull the stuff by opening another checkout lines. That's what we call real-time queue analytics. We also have dual-time monitoring. Now, this technique is actually used for the new products promotion. So for instance, I put new products on the shelf and I will actually use the camera to observe all the customers' purchasing behavior, how they actually react or interact with the new promotions. Now, and also, we also deploy camera in the municipal surveillance. We we have these two techniques like face detection and license plate. These two can actually speed up in the criminal cases as well as find personal interest. And under the electricity facility, we have these two here, intrusion detection and remote monitoring. Now for the intrusion detection, it's just we use a camera to actually connect the alarm sensors. Someone actually goes in and will be detected, so the alarm signal will be actually sent back to the control. Yeah. As for remote monitoring, we can use it if you have multiple sites in different areas. So this is just for normally it's actually used for centralized management. Also in the factory we have people counting. Now this technique can be used, for instance like forklift. We can actually mark an area, say how many times the forklift will enter in this area to load and unload the shipment. So this technique can actually optimize the stock levels. Let's move on to the next page. On the left-hand side, we have you can see that there are multiple person to monitor one camera. So this is actually for a typical home application, and for this camera we can open more than one stream, more than one video stream, so that either way inside the office you can actually monitor your camera in your home place. On the right hand side you have a typical MVR, and all these cameras connect to an MVR just for sending the video recording. Now, just by the way, for the traffic, this will be the unicast traffic. Okay, what it means is actually the traffic goes from the source to the destination. Okay, and here if you have multiple, let's say more than one video stream, you want to monitor, you can use multicast. Now, multicast multicast will actually reduce the bandwidth consumption. So, for instance, you open two. Let's say there are two people trying to monitor the same camera, but actually there's only one frame being sent out by this camera. Now, here's just a typical CMS. Okay, normally we will use one MVR to manage multiple MVRs. And in this scenario, we only have one entry point, and that's the centralized MVR. We actually connect to a centralized MVR, and if we want to actually see other sub-channels camera video footage, we can just log on to it. Okay. This just helps us to unify every single devices and provide us a central point of management. And this is actually typical what we can see inside the airport, or if you have multiple sites just mentioned in the previous slides. How do we actually select the right Ethernet networking devices? Well, there are three factors that we have to consider. The first one is actually the environment. Now it's very important. Let's say if you actually install a switch inside a place where there's an air conditioner. In this case, you don't need to have to install industrial switch, because you have air conditioner to help you to cool down the devices. But if you want to install a device in a traffic cabinet, in this case, you would definitely need an industrial switch, because it is able to withstand extreme temperature from -40 to +75 degrees. Okay. If you want to install switch in a power plant or railway, then for the power plant, the switch has to be IEC standard, because the switch needs immunity to the EMI request of reference. For the railway, you have to have like EN standard for the railways. Now, bandwidth requirements. Okay, it depends on the number of cameras we have, and also the size of your network. You can actually use the online calculator to calculate the bandwidth of each camera. There are some couple of calculators, such as neural calculator, that gives you the option to select compression codec, frame rate per second and type of resolution that you want in order to calculate the bandwidth. As for the installation, we have to think about whether it's actually PoE based or non-PoE. For our switch, even though it's even it's a PoE switch, we can also shut down the PoE as well. So there's no difference if you just think that PoE is not necessary. We can also do that. Now, for these three types, manage, web smart, and unmanagement. Okay, web smart is just a simplifier of management switches. These two differences, you can easily find out that management switch have SAMP features, whereas web smart they don't. Normally, it's just provided a simple user interface and let you to do simple management. As for the unmanagement switch, it's just simply plug and play, and that's it. There's no GUI involved in this device. Okay, in this section, I'm just going to talk about how to optimize network transmission and installation. Okay, why do we have video lag, like video latency? Do we just blame for the network performance? Sometimes no. We have to consider the total latency. Okay. The total latency is actually equals to the processing latency. What I'm trying to say is that when the camera capture the events, they need some time to process it, and they also need to do some encoding. Now, this is what we call the processing latency. Now, when the encoding is done or is finished, it's gonna transfer the frames over the network. Now, in this case, you will have propagation latency. Now, when the frames arrives at the destination PC or NVR, they have a buffer to rearrange those frames because those frames did not actually arrive in a sequential order. So you have to actually rearrange it. So in this time, what we have is the decoding or buffering latency. So these are the three factors that we need to consider. Okay, here just a quick example. Let's say if I'm using the PC to watch the videos. I've done the updating drivers, but somehow I just have video latency. In this case, you can actually roll back the driver to the previous states in order to solve this issue. With regard to NVR, for instance, since we have latency, they will definitely have the packet loss. In this instance, what we can do, we can increase the frame rate. So increased frame rate will compensate those packet loss as well. Okay, channels, we have to make sure the NVR, how many channels that we purchase. For instance, let's say NVR supports 3 cameras. So you cannot add the 4th camera to it because it's due to the channel. And each channel will actually have a specified resolution as well. So you cannot actually, let's say the maximum resolution that a channel can support is Full HD, and you configure more, let's say 3 megapixel, it won't actually work in that way. So also for the resolution, well, sometimes we can reduce resolution to solve the latency issue. Now codec, I will talk about codec in the next couple of slides. As for the bandwidth, there are 2 types, wired and wireless transmission. For the wireless transmission, it's actually in the half duplex mode. So sometimes you have transmission problems in wireless. In this case, what you can do is actually to enable RTS and CTS. What the RTS does is actually before I sending traffic from camera to the wireless access point, I send a request, RTS request for permission. So to ask the AP to give me permission to send. In this way, the further collision can be avoided. This is how we use half duplex in a wireless environment. So I will prefer to use wire. Wire has a better performance than wireless because there are some hidden points in wireless as well. Now, half duplex and full duplex, the difference is that you cannot actually send and receive device at the same time. This is what we call half duplex. For the full duplex, you can send and receive at the same time. So that's the major difference. When you actually encounter bottleneck, you can actually select a gigabit uplink port to solve this issue. This one normally is used when you want to cascading switch all together. So you use the uplink port with aggregated bandwidth. So it helps you to actually reduce the bandwidth issue. Now here we have image distortion. Now these are the following are just other factors that cause the packet loss. For the network congestions, I will talk about later on. Codec compression. Well, there are some difference between different codecs. Let's say the H.264. They were only actually encoding the differences among contiguous frame, whereas motion JPEG is a little different. Each frame will be encoded. Now, the thing is, for the H.264, if you encounter packet loss, you have the image distortion. So in this case, you can actually change to motion JPEG if you have enough bandwidth. Losing some packets will not actually cause serious issues. Now, we also have for the graphics card performance, you need to choose, if you watch videos on the PC, you need to choose a better GPU performance. Okay. As for 4D cable connectors, well, this one there's nothing to do. We cannot do anything about it. What we can do is actually to replace a cable, and that's it. Band cable will actually result an intermittent connection. What it does is actually, if you try to ping a device, you receive a couple of replies from the device back, but suddenly you receive requested timeout message. Now in this case, it's actually mostly due to the band cable. So you can either make the cable straight or by just simply replace the cable as well. Okay, let's move on to the next page. For the frozen screen and video loss, these are just a couple of factors. Now, the first thing is actually the cable gets disconnected. They can be actually done intentionally or just by tripping the cable. So in order to avoid it, just make sure you have you put your device in a safety area. Okay. Now, for the vibration environment, we suggest to use M12 connector. Sometimes you put a switch on the train carriage. If you're using a regular switch, you will easily get a losing cable. So it's better to use M12 as well. Okay. If it's camera hardware issues, well, there's nothing more we can do about it. We have to send away for IMA. Switch breakdown, this time can be avoided. We can try to put a switch, place a switch in a cooler place and see whether the overheating issue can be solved. Okay. As for non-PoE power output, normally it's actually due to the power budget. So before you deploy any PoE devices, you have to calculate a total. If the device have a total around 240 watts, you cannot actually have a total more than that, like 300. It won't actually work. Okay. Now this one is just for the non-compliant IEEE standard. Some devices will actually they don't follow it. It's just simply connect device to our switch and we won't actually produce any PoE output. Now, as for the network congestions, we have here. There's just. Do you guys remember the first slide that I will show you that by placing a hub in the middle, we will end up like this. So you have multicast, broadcast. So in order to avoid the situation, it's just to use a switch, use a management switch, and apply virtual loop. Okay, looping. Looping is actually normally causing by unmanagement switch. You have two switch and you plug in two cables and you automatically end up with looping. So in order to avoid this is to use a management switch. So you can have the redundancy as well as enabling the rapid spanning tree to avoid the loop. Okay. If you're actually running out of bandwidth, you can actually enable quality of service. Now, once you enable this functionality on the switch, all the traffic will be prioritized based on your decision. Okay, without actually enabling this function, you will end up the traffic goes first in, first out, and that's it. Virtually, as I mentioned before, we can use it to segment the traffic as well. IGMP snooping. What the snooping means is actually IGMP examining the layer 3 packet header. What it does is actually when you enable multicast on a camera or on any device, the switch doesn't know it, so you have to enable IGMP in order to manage the host to join the school. So this functionality, otherwise if you don't enable it, it will end up broadcast as well. Okay. Now, as for the ESD search and protection, okay. For the ESD, normally when we get ESD because we are actually having two non-conductive materials, we just rub them together so we get ESD. In order to avoid that, the best way is to purchase a switch with the ESD protection. That's the one way that we can do it. Second thing, with regard to lightning strike, okay, lightning can actually damage the device in two ways. Now the first thing is just the device is being struck by the lightning directly. In this case, there's not much we can do about it. If the lightning hits the nearby area and causes the filter transient voltage, then in the second instance we can install a power surge to protect it, okay, to protect the device from being damaged. Now also implementing grounding is also important. All our devices have the earth ground, so that you to implement the ground. So in order to divert the electrons from the device to the earth surface. Okay, here just our case studies. In this application, we have a Japanese freeway. Now, each booth, what we have here is the roadside telephone service, emergency service. Now, each booth is actually have space at 1 kilometers, like in this direction. So what the customer wants is actually they want to use the camera to monitor their telephone, so they can find out whether the telephone service is actually in use or being tampered with. So what we suggest is to use an EX78000 device. Now this device is able to withstand extreme temperature because, as you can see, all the device will be installed inside the cabinet. So that's what we suggest them to use. We also suggest them to configure alpha ray. The reason to use alpha ray redundancy is actually it has 15 milliseconds of recovery time, comparing to the traditional rapid spanning tree takes about 3 to 5 seconds. It's much more faster because applications like camera, view, or voice over IP, they are critical applications. So normally we require fast recoveries in order to handle this type of application. Okay, here is our Taiwan highway. This project involves a diversified of end devices. So as you can see, our device is able to connect the digital signage as well as those traffic lights. Okay. So and wind sensors. Now the most for this particular device, I have actually highlighted is our media converter. What the customer wants is actually they want to have a link fault detection. So if something goes wrong between the links, they can find out inside the control. Okay, as you can see, all these are already implemented because these are all the critical applications. Now here we just have a typical power plant surveillance, but because our customer is actually running out of budget, so we ask them to use the media converters to replace some of the switch. Now media converter can actually have some advantage. They can, first of all, we can use fiber to have a distance. We can increase distance as well as their EMI emitter as well. So you can see it's fiber because these are the substations. They would produce the radio interference. So implementing the fiber will be a better choice for this project. Also, we have here is the automated optical inspection. What the customer wants us actually to use a high-resolution IP camera to monitor their PCBs. So we offer the EX78900. As you can see, these boards are all the gigabits board. We make sure that there's no bottleneck on the bandwidth. So that's why we suggested to use this device. As you can see from this special device EX71000, we also implement the alarm, external alarm system. So just in case if the power goes down, the alarm will send back alarm signal back to the control room, so they can actually troubleshoot it immediately. Okay, here's just another typical real-time surveillance. We choose these two switches because they have the easiest graphical user interface. So it's actually easy. They can use it to easily manage these PoE cameras. Finally, it's our last case. What we have here is that in a hospital where we have more than 460 cameras, and each building will have on average 150 cameras. So there is a little bit inaccuracy in this diagram because what we want to emphasize is these devices that we want to use them to connect the cameras at the end. Okay. Now you can see the EX25611. This is I will actually say a best switch because when you're doing network expansion, if you actually have multiple switches, you try to stacking together. You can use a feature called virtual stack. In a traditional stacking, you have to use stacking cable. Now in a virtual stack, you only need to use Ethernet cable to chain up the device, and you can manage these devices under a single IP address. Now that's the beauty of it. So, here's just our competitive advantage. We have the best R&D team to develop our own Linux kernel. We can actually solve issues much more quicker comparing to our competitors. Flexibility, as you can see in both cases, we have a diversified range of products like media converters, PoE switches. We have a flexible solution for implemented for depends on the user scenario. Okay. We also added value to our products. Before we do any deployment, we will actually have a careful evaluation with regarding to clients' network topology. We also will actually test our device before physically implemented. Okay. And also, these are our core technology, Alpha Ring and Alpha Chain. Now, this is the best redundancy protocol. Alpha Chain is a little bit different than Alpha Ring. Alpha Chain is actually can be used to connect third-party devices like PLC or any unmanagement switches. But Alpha Ring only runs our own switches. Okay, so there's a little bit different, but they are all doing the same for the redundancy. Okay, here's just our strategic business partners. We have Bosch and New York City Transit. Now these two companies use our PoE solution to implement their IP surveillance camera. And if you think connectivity is crucial, just put us on your list. We will definitely help you. That's the end of our presentation. Thanks so much for playing. Sorry. Any questions that you guys?
About the broadcast.
Broadcast domain. Yes.
Say, yeah.
Yeah.
Typically, how many cameras or how many NVR or how many clients when they group together, they start